Okay, we are continuing on with 10.8. I'm trying to break them up into smaller segments so you can watch them bit by bit if you wish. All right, so we were talking about vectors. We determined whether or not they were equal magnitude and same direction, whether or not the vectors were equivalent. So we can also do operations, vector operations, probably the easiest part to vectors, honestly. So let's just say we have, let's say vector operations is what we're talking about here. Vector operations. It almost seems too easy to be in pre-calculus. So we have scalar addition. Scalar addition. So let's say we have a vector. We're going to call it vector u, and it has u1 and the components u1 and u2. We have vector v, and we're going to give its two components v1 and v2. So we can sum two vectors. We can say vector u plus vector v. All we do is add the, change my pencil here, add the first components and then add the second components. It's that easy. So we're going to say to sum two vectors, we just are going to say u1 plus v1, comma, u2 plus v2. Note that instead of parentheses like we did when we were talking about a point, we use these little arrows to indicate that we are now in vector form as opposed to point form. So summing two vectors is that basic. So let's sum two vectors. Not that we really need to, but we will anyways. So let's just say we have vector v is negative 2, 5, and we have vector w is 3, 4. If we wanted to see the sum of vector v plus vector w, we would literally just add negative 2 plus 3, and then 5 and 4. And that will give us 1, 9. That easy. All right, we also can multiply a vector by a scalar. I'm going to switch back to blue. A scalar is just basically a constant. So let's just say we have k times vector u. K is just a real number. This is the equivalent. So if we have k times vector u, the two components, u1 and u2, the k can distribute just like it does in algebra. So k u1, comma k u2. That easy. So let's just say we had, let's use the same vector v up here. Sorry, my dogs are out. So let's say we had 2 times vector v. That means 2 times negative 2, 5. In scalar multiplication, all we do is just say 2 times negative 2 is negative 4, and then 2 times 5 is 10. It is that easy. We also have subtraction. It's really the negative is what we would say as opposed to the subtraction, but it works exactly the same. So let's just say we have u minus v. This is the equivalent of vector u plus the negative of vector v. Oh gosh, that's not a, sorry about that. Not sure what happened there. All right, go back to the pen. There we go. So let's just say we wanted to take w from up above. We wanted to say w vector w minus vector v. That would be w we said was 3, 4, and v was negative 2, 5. So we're going to subtract negative 2, 5, and we're going to subtract each component just like you might imagine. So we're going to get 5 because 3 minus negative 2 will be positive 5. And then negative 1 because 4 minus 5, oh my goodness, is negative 1. So that's our vector operations. Really